Okay, so today we're going to look at what will be the acceleration of a balloon that has a buoyant force of 20 newtons and a mass of 500 grams. So the first thing I'm going to do when I look at this problem, 500 grams, that's wonderful, except it's not MKS units. So I'm going to go ahead and convert this into 0.5 kilograms. And I will gently scratch that out. 0.5 kilograms. The amateur physics student will look at this problem and say, well, I know that F net equals ma, so I'll see a force of 20 and a mass of 0.5, and they'll try to solve. Is that a good idea? That's a terrible plan. What's wrong with that? Well, remember this says the net force, which is all forces. Have you considered all forces? I don't think you have. The buoyant force is 20. It didn't say the net force was 20. It said the buoyant force was 20. So we need to worry about what forces are acting on this problem. So let's do that with a free body diagram. So here's my balloon, and I'm going to write in 0.5 kilograms. Now we learned that there is a force pulling down, your gravitational force or your weight. And you know how to calculate this by using the formula mass times gravity. So what is the mass of this balloon? The mass of this balloon is 0.5. So we'll step up here. Fg equals 0.5. And we know that gravity is 9.8. 0.5 times 9.8. Well, it would be a lot easier in this problem if we use 10 for gravity. So just for the video and for today's notes, let's use 10 for gravity. That'll make our numbers real easy, and we won't even need a calculator. So 0.5 times 10, we can do that in our head, 5 newtons. So in my free body diagram, my gravitational force is 5 newtons. We need to worry about gravity because this balloon is traveling up. So the gravitational weight is 5 newtons. What was the buoyant force? And that was given earlier in our problem. That was 20 newtons. So the buoyant force was 20. So the buoyant force, 20 newtons. The gravitational force of 5 newtons. If I take these two facts together, now I can calculate the net force. We will simply subtract because they're moving in opposite directions. So in this problem, the net force is 20 minus 5, or 15 newtons upward. I'm really glad this force of upward is 15 newtons, because otherwise your balloon would sink. And nobody wants a balloon that sinks. Now, let's calculate using Fma. F net equals ma. The upward force is 15 newtons. The mass of the balloon, remember we're not going to put 500, we gently scratch that out. It's 0.5. So 15 equals 0.5 times a, and then we can solve. 15 divided by 0.5 is 30. So for this problem, the acceleration is 30 meters per second squared. Now that's going to be a nice violent acceleration upward, 3 times acceleration due to gravity.